Please.
Hello, my name is Oleksandra Konopatska, and here is my thesis on topic text generation with control conditions compliance under the supervision of Untitled Chapter. So firstly, I would like to tell what is the control of text generation. The generation is when we generate a text which is not just a text, but text which comply with some control conditions. For example, on this example, we see that we have sentiment positive, and we would like to generate positive sentence, and the generative model generates for us sentence, "I'm very happy to be with you," and happy indicates that this sentence is positive. Control conditions would be different. They can be sentiment, topic, which is semantic control conditions. They can be structural, like syntax tree or part of speech structure. They can be lexical, and so on. There are different approaches to conditional text generation. It evolves in recent years. First of them are some approaches like racial encoders, GANs, and interface models, and they all are very based and very rely on large-scale data sets. There are classical approach which is now large regressive language models. It's require also a long time for training and for fine-tuning, and training for training models for specific tasks can be very hard and complex task. There are non-regressive language models. They are very good for some tasks of machine translation, but not very good with text generation, with text modeling. There are light-weighted plug-and-play approaches which keep the language model fixed, and they steer the generation towards some control conditions by the external classifiers. And there are different models which works the same way. And there was some more lightweight approaches, but they still have some restriction limitations. And overall control text generation model have large room for improvement. So heavy models show good results for that. So heavy models, smaller models are solving mostly small specific tasks they trained on simple data set, and even larger models, they have some difficulties to comply with some of the control tasks. So in our work, we want to comprehensively explore approaches to supervise text generation on a spectrum of problems and on a data set with large vocabulary. Our hypotheses for this work are that we would see the stable performance of large regressive language model, which are a classical approach. We expected the promising results from diffusion-based approaches, and they could be trained on the large vocabulary data set. And we also expected the ChatGPT's rockstar approach nowadays. We would like to conduct experiments with that, and it will outperform all the approaches on all the tasks, because we all are now very impressed with the ChatGPT work on different tasks. Which type of control generation we like to solve? There are 5 of them. First is length control, and here is the example of length control. So we have one prompt, we have length 6, and we have now, which consists of 6 words and punctuation symbols. Also, we have a task of parts of speech control, which is structure of parts of speeches, sentiment control, which generates positive, neutral, or negative text, tense control is past tense, past, future tense, and present tense, and multi-conditional generation, which combines this together. Semantic control, which sentiment, tense, and part of speech structure. And here is the example of how it works: positive and past tense, and with even part of speech structure, we have our which comply with all of this. Our goals and ideas were based on the classical approach, check the possibility of its fine-tuning for various tasks of text generation, try to adapt existing diffusion solutions to the task of control generation, and conduct experiments with ChatGPT, particularly on those tasks potentially cause difficulties for them, because sentiment and tense are not really a problem, but length, part of speech control are more complex tasks and for ChatGPT, and we will see it later. And all of this on our own set, and this specific design set of metrics. That said, the motivation behind the creation of our set was to have full control over training data and to make a proper analysis of different facets of the generation task, and whether there are no standard for problem of controllable text generation, and especially multi-conditional text generation. So we it was a logical step for us. How we created our data set? We took open web text, which is a collection of web texts sampled by the principle of quality. It's different web texts from different web pages, historical publications, some tutorials with code even. We sampled from them 10,000 paragraphs, which in total is 450,000 sentences. We made first cleaning to avoid strings, links, email addresses, and other things. Then we add attributes, we'll talk about on the next slide, and we make the next cleaning, which is sanity check after the adding attributes, and resulted with 369,000 sentences with attributes. The attributes which we added are those correspond to the tasks we want to solve, with for every sentence is length, it's part of speech structure, it's sentiment, which is in numbers, but actually it's positive, neutral, and negative sentiment, and stats. From this big data set, we sampled a smaller training data set in which we conduct our training. It consists of 100,000 sentences. Its distribution of lengths is equal of distribution of lengths of the original data set which we sampled. And the reason behind making training data set is to have a huge training, because the training of the larger data set require much more computational resources, and second is to balance some of the parameters, especially the sentiment and tense, because on the original data sets were more neutral sentences and lack of future tense, and it was very imbalanced. So we tried to fix it in this sampling of this smaller training data set. For our assessment of our models, we designed a set of metrics. It's based on the previous work in comparable text generation, especially diffusion models and papers on diffusion models, but it's making it's more comprehensive, and it's metrics which are specifically for our tasks. So we want to our model and our generation results to comply with control condition first, because it's what we want. Yeah, we want it to be like positive or to have specific lengths. We want also metrics for fluency text, so we don't want it to be like nonsense. And also this text should be distinctiveness, so we don't want the model to generate the same text all the time. And we also want to be unique, so it will not generate the text which it already seen in the training data. For compliance with control conditions, we have a set of metrics for each of the tasks. For lengths, it's exact lengths, the compliance with lengths, approximate lengths, which plus minus 3 words and punctuation symbols, and is mean deviation length, which simple will mean of deviation from the desired control condition. For part of speech, we have a set also of metrics, which is exact compliance with the exact structure, presence of unique part of speech, which we want, and grammar compliance, and alignment post. I will talk about it next slide. And sentiment is exact sentiment and approximate sentiment, which is plus minus 1 sentiment level, because negative and positive often means you understand with natural, and tenses of one matrix, which is the exact tense. So for part of speech, what we did, we thought that probably it will not preserve the all the text, but maybe with some gaps or maybe with some additional tokens. So we first align them in this matrix. We align them so they correspond to each other, and then we calculate the percentage of texts which are matched in this alignment sequences. For assessing fluency, we use perplexity metrics. For distinctiveness, we use several metrics, which use this ending in the beginning, this in rounds, and also we have specific metrics for part of speech. So we tested it on, we use one part of speech structure, and that's how it can generate a distinct generation under same part of speech structure. And for repetition, we have just repetition and rounds, number of unique graphs. So for models, we fine-tuned the classical GPT-2 on our tasks, and resulted in 5 fine-tuned models, length, post, sentiment, and so on. Here is an example of training example. So each training sample has this specific conditional tokens and also start and end token and control conditions. For diffusion-based models, we used 2022 approach of diffusion lab, and it's minimalized version, minimal data diffusion. Diffusion models are working by gradually adding Gaussian noise to destroy the training data, and then train to reverse the process and restore the training data. And then they can use the same approach to generate the data, generate the text embeddings from the Gaussian noise. For ChatGPT, we used the simple ChatGPT website, and here is the example of prompt how we asked it to make part of speech structure, and the results it gave us. Generally, we received very good results for GPT-2. We can see, for example, here is the results of part of speech, but I show later for other models as well. So we can see that it can observe even some comprehensive things like the symbols, like numbers, and to understand how to generate sentences with the symbols and numbers. And it's still believed because we have 9 distinct measures, so it's not what it saw in the training data. For the results, on the matrix, GPT-2 show exact length of 42%, but for approximate length, it's much higher. So it's comply with the control condition, but approximately. And we see that mean deviation pretty good, 1.5 words. For exact sentiment is 73%. The tense is the best metric, so it's 98% compliance with tense. And for POS, it's harder for him for model to preserve the exact speech structure, but for aligning POS with this it works good. It's about single models, and for multi-conditional models, we have slightly worse results for tense and sentiment, but part of speech is still good. And we can see that it's hard for problem starts for lengths with the long sentence. GPT-2. So for small sentences, we generate good results, and approximate length is 100%. But after like 40 words, it dramatically falls, and for the extra long sentences, it has to generate it's a very big deviation from what we want. Also, for perplexity. When part of speech structure appears, complexity become higher. So when higher complexity is worse fluency of the model. It's pretty obvious because when we give it a specific structure and try to comply with this structure, and sometimes it costs some fluency of the generation. Unfortunately, the diffusion models didn't work as well as we expected, so it didn't work on our large custom data set. It trained, but it showed not very good results. You can see the example of it. So it's not fluent, and it's text, not fluent text to be expected. We think that much more training time and much larger data set, more steps required for it, and so it requires a lot of more computational power, which is not possible under our work. And one of the reasons behind this is that GPT model, for example, which worked, was pre-trained, and we will work on fine-tuning, but diffusion models, they should be trained from scratch, and approaches which we use, which is diffusion alarm and minimal time diffusion, they on their work, they after a small data set, so they use restaurant reviews or simple stories, and they have a very simple data set on which they can train, and they have good results, but on this large topic data set, it didn't work. So more experiments needed here. For ChatGPT, results was interesting. So we didn't have better results than GPT-2. Actual length is worse, and part of speech is very bad. But with part of speech is most likely because if ChatGPT didn't explicitly see this part of speech text before, GPT-2 was fine-tuned this text, but ChatGPT was given this text, and but it tried to preserve the structure, so with the alignment was still good, and try to generate in this part of speech structure. But ChatGPT showed much more stable performance. So we see that its length, and as we saw that GPT-2, after 40 words, it starts to fail to generate sentences with given length. But ChatGPT was more stably all over this, or even longer sentences. But it was mentioned that after some number of words, 50, it starts to generate not a sentences but a paragraphs with given length. Yeah, so summary, summary is that GPT performed well on all task metrics. GPT is more stable for length control, yet it short words results. It generates only similar sentences to the given part of speech structure, while GPT preserve structure. When part of speech become part of the control, complexity goes worse. And we also did some experiments with distinctness, so we add more generation samples, so more generation, and with more generation, of course, distinctness go over. So it's pretty obvious, but it's still pretty nice. ChatGPT often generates sentences with similar beginnings, especially after some time. And for different models, we much more computational resources to provide experiments with them. So summary and future work, we have 5 training models trained on the data set and set on the tailored set of metrics. We see great performance of GPT-2 on all tasks, but more experiments with lengths can be done and needed. Different models have plenty of room to improve, and ChatGPT isn't the all-purpose solution. And also it's interesting and worth researching other control conditions, which is dependency trees, lack of toxicity, etc. So, thank you very much, and please ask questions.
In general, post is very important. Very interesting topic, and controllable generation is very interesting, but why less? What is the reason for that exact answer?
The reason in real world or in the research that
Still, like yes, for research mean of getting exact answer of generation.
I mentioned, for example, generating model from everywhere and everywhere, and all the web resources. And for example, on some places, web resources, there are a limited number of characters, or they should. Sometimes you need to restrict ChatGPT to generate one sentence for you or 2 paragraphs for you, or other language ones. You don't need if you ask ChatGPT to write something shortly and then write for you an article. And
Yeah, but is it really required to have like precise length and like put it as metric? So that
why we have different metrics, so we see how it make it exact and how it make it approximately. And for example, GPT-2, when we ask it to write 50 words, it generates something like 30 words, it's different at all. But for ChatGPT, it's plus minus and the approximate metrics.
Okay, and you say that it was trained from scratch?
It's fine.
Fine. And how long it was and what are like hardware requirements?
Yes, sure. Training one model took about 12 hours, and we used one instance on to train one model. It's approximately.
Which kind of which kind of
Like
top model or average?
Actually,
that's nice. Okay. 12 hours. Yes.
My question is that you take your
contribution is the fine-tuning GPT-2, and then we compare it with the ChatGPT, and ChatGPT is like 3.5 year model.
Yeah.
And we also have paid version, we have the ChatGPT 4 version, we have solution from Google, we have other solutions. Why you choose only one to compare?
Yeah, we choose a most acceptable way to compare, but sure, the direction we would like to compare like chatbots between each other is, of course, we should be compared with each other. And all this always involved very quickly.
Today, it is very like topical task to fine tune or train some kind of one large language model, yeah, for specific like topic domain, yeah, domain of knowledge. And what is the reason for this system? Like to speak about some domain, yeah, some area of knowledge, or answer questions more interestingly. What do you think about this kind of application of your results?
Yeah, sure. So this is what I told about in the last comment. So other control conditions can be and should be researched. For example, we can have lack of toxicity, which we cannot explicitly because it's kind of like figures of toxicity or no toxicity, or we can add even topic and some kind of control for the topic and fine tuning similar variables.
So you mentioned like topicality, yes?
Yeah, we kind of use that for it because there is some classifier to classify the basic sentences, the topics, and then to make the continuity.
Yes, of course, but have you tried to measure some kind of if results like virus? So if this pre-trained model answers or speaks like correctly in terms of this topic,
We didn't change it for topic. So because for training for topic, we need this topic attribute, and for making topic attribute, we need to make specific classification model and then process it, and it's different data set. So we don't need this data set, we simply do the kind of it.
maybe I mean slightly not. For example, ChatGPT tries to answer correctly for your questions. Yeah. And is this your fine-tuning model tries to answer correctly?
Yeah, we don't ask it anything. We didn't say for it like we so we say it should be negative, sentence or negative sentence in present tense, and this is structure, and it shows the executor which is really negative for present tense. So it combines with specific control conditions.
Yes, I remember specific conditions.
Yeah.
My question: why you haven't challenged this question? Why haven't asked this question? It was out of scope, just.
Yeah, it was out of scope. We can write out some prompts, but actually it's not.
What is the background of the text that you ask your model to generate? Is it in terms of an individual sentence, or is it a paragraph, or is it 12 pages, or?
Yeah, for our data set, we constrained it to the 80 sentences, so it is distributed. Yeah, so we constrained it to 8 words. So it's in training data set, we don't see more than 8 words, so we generate it also. No more than 8. But yeah, so the GPT generates sentence, even large sentence, but it tries to generate one sentence, but then the
So does your model generate individual sentences or paragraphs of several sentences?
Individual sentences, but it needs to be changed a little bit and generate different sentences because long sentences are actually more.
Would it be able to generate word stories?
Probably because it can generate like long sentences, so it can generate stories.
I can probably a crash test if you wish. I can supply with the full text for all my papers, which I have written in my lab. It's about 150. So if you pre-process and receive it as a data set training, will it generate a new paper
A new paper.
with a distinct contribution? Or what?
Well, it would generate some fluent text, but
Which is also good.
yeah, that's another habit I think about.
Have you thought of trying this test on the system?
So we need to,
It's not a data generation is a good test for any text process, the initial text process.
be sure, but I'd think of the control condition because it's more like control the data generation. And, so we want to fine tune it on the data set existed of papers.
So you may wish to do whatever you like with those texts processing, like chunking into individual sentences, like chunking into individual paragraphs. Whatever.
It is trying to fine tune on open web text, so it's some more news articles and all this, and if it doesn't generate something like this, it will probably generate, but this one, it will be in publicity style, but we didn't train it, so we need to train them on this article, fine tune this.
So I thought what happens writing the paper. And you review it, okay.
Right.
The smarter reviews. Thank you.
You mentioned that you collected the data sets from the impact.
Yeah, it's out of selected of the open objects.
It was really used.
Yeah, very recent.
So my question was about reproducibility. If you test, if you train different data sets, as Vladyslav suggested, for instance,
Yeah.
can you predict what if these stores you showed us will change?
You should be tested and see.
Sorry, I have one more question. Will it work on the qualification?
Yeah.
It's like-
Yeah, because it's kind of in digital, yeah. But we can,
But the approaches are more so. That's true.
approach is now a super lot of, if we take a GPT-2, which was portrayed on English, so we need to change it, and then we need to find twenty other.
So you train it in the
Yeah, but
use of a certain data set. So if you train it on the graded data set, you generate a graded sentence.
probably because we have very small data that we use here for training, and I can learn to make it fluent from the small amount. So obviously, diffusion model that is good for small amount of data.
So it was. So I have
Just imagine, would you apply results for generating, for example, answer to email thread? If it would be the training on the
Language model.
no solution to do that.
Mhm.
Yeah, okay.
Thank you.
Hello everyone, my name is Vlad. I'm about to present my master thesis on astronomical data features extraction and citation prediction. A short intro is that this research was mostly targeted to extract information from the astronomical telegrams with a specific target to predict the future citation rate. And first, let's try to understand what are these astronomical telegrams and why are they important in the domain. Basically, these are the online services, called the websites, where each astronomer from the separate individuals up to the largest research groups in NASA can share their observations and post them to discuss it with the community. There are two main sources of such astronomical telegrams, namely the astronomical telegram itself and the GCN. Both were founded in the late 20s and became more and more popular recently. Worth mentioning that throughout the research, we were communicating with the astronomers from the European Research Center, and they confirmed that they are using this stuff and it is important for them. So let's imagine you are an average astronomer and you want to know what's happening in the world. You go to the websites of what challenges will face you, or you will face. First of all, it's the data complexity. There are a diverse range of different telescopes, planets, galaxies, and you cannot know them all even if you're super professional. Of course, the diversity in sources and different data structure in those sources, and the data volumes. So if you want to check the current direction of astronomy, let's say once per week, you will face dozens of observations. Some of them might be very long. So it's naturally that you can think that some NLP methods might be very appropriate tool of analyzing and help the astronomers in this field. However, the NLP methods in astronomy are relatively unexplored, with only a few related papers over the last decades. And yes, so we're ready to set up the goals for the research. First of all, we wanted to create a data set suitable for analysis and for the subsequent tasks. Secondly, we want to extract some information, using different ML techniques, the information that can help to better explain and understand the telegrams. And the last target is that we want to predict or detect the impactful telegrams. Further in the research, we will reference the impactful telegrams as interesting ones. And we'll start with the data set creation. So basically, we utilize the Python libraries, beautiful soup, with the set of regular expressions, and we parsed all the telegrams that were available at the moment for both ATL and GCN. Each telegram was indexing with its number on the source and the source itself. We unified the format across these websites, and we extracted all the references and citations that are made on those telegrams. And also, the scripts that you made are kind of can be further utilized to have some data and data set up. So an example of citation you can see above we are citing the GCN, below we are citing the ATL. So good for us, there are some agreed rules how the astronomer should refer to some other's work. So with the set of regular expressions, we were able to extract most of the citations. A brief explanation of exploration of the telegram strand. On upper part, you can see that the amount of telegrams were rising through the years with the peak in the 2019. Below you can see the amount of telegrams by months, which actually corresponds to the real scenario when for instance, when beginning on the spring and beginning of the autumn, the Earth's position in space is much more fitable for some observation. The galaxy center is more observable, so there are much more telegrams. Now we have to define the target variable for the citation prediction task. Right, so we know that some telegrams are citing others. So the telegrams which are being cited get +1 to their citation rate. Now we have to understand the distribution of the citations. Basically, the median is 0, which means that at least the half of the telegrams are never cited. So for our future citation prediction task, we want to like approach it in the classification like manner. So we set a clear threshold of minimum 3 citations. So the telegrams with the all 3 citations are going to be like the interesting ones or impactful ones. Additionally, for the research purposes, we set up a threshold of the upper 5th percentile, defining the class of like super interesting telegrams. So the final classification task target value distribution looks like this. Yeah, it refers us to the highly unbalanced classification problem, and we'll look into detailed methods that we used in the experiment section. Additional step that we made was to remove the self-mentions, self-citations, yeah, when some authors do some follow-ups on the previous jobs. We removed the duplicates between the RTL and GCNs. And we also created a preprocessed version of the telegram bodies following like the standard NLP practices. The first step in the information extraction was to create a named entity recognition model. Basically, interacting with our astronomical colleagues, they pointed us that the most significant entities that we can find is the telescopes and sources, without like any division in the planets, galaxies. Yeah, the sources, an object we observe, and the tool we observe this object with. They already provided us with some set of values that they were tracking using the regex rules. But we iterated through the model training a couple of times. We discovered that there are not enough labels for the model. So we also additionally parsed the Wikipedia and obtained like twice more labels. You can like briefly explore the label body. Yes, some text, we got a source, we got a telescope, and this label body was then sent to the model. And the model, the decision of our choice here was the space. I bet you all know about the space where you have the tool. So we trained the space on based on the smallest model, used mainly the full model setting and some validation data. On the validation, we achieved a pretty good F-score. And on inference, by the inference, we will reference to the model inference on all data, training and validation. On inference, we achieved really good coverage of entities. We found on average above 3 entities per telegram, and 97% of telegrams had some entities found. An example of an NER result here, but have to read through all of this, but just to have an intuition of what the telegram bodies look like, how the NER results would look like. Also we compared the results of the space NER and the rule-based, like the regex rules we used for labeling, and found out that some entities, we are finding some new entities, but at the same time we are missing some entities that were in the label data. So at the end of the day, we decided to consider the final NER model as the combination of the trained model and the regex patterns we used for the labeling. A couple of interesting distribution that we can inspect is that if we build a distribution of found sources by its citation class, we can notice that, for instance, some sources like the sun, I believe it's like 7th or 8th on the left, are mainly assigned to an unsighted class, which is pretty logical, right? Like we can see sun all the day, why would we care about it? And at the same time, some sources like the black hole or neutron star on the right side are mostly assigned to the very sighted class. And this chart itself gives us an intuition that probably some decision tree based algorithm can handle this data and can separate the telegrams based on the extracted entities. The next step in the information extraction task was the topics extraction. The idea is very simple. We want to know which topics are discussed in the telegrams. Right? First of all, we had to start with some data, with some labels to train the model. And lucky for us, the RTL website already has some functionality, so we were able to just make an additional regex and get all the subjects. So this, which means that all RTLs were already labeled with the topics, and lucky for us, like these topics were put by the authors themselves. So it's the perfectly labeled data for the task. This time we wanted to incorporate some of the more fashionable trending solution, OpenAI. I know you know about it, like about this current GPT-4 and other stuff, but in our case, we employ the other model like it's the recommendation of OpenAI themselves that for the simple task, you should use the other model as the cheapest and the fastest. So a couple of details about the topic model. First of all, it costed us less than $50. It was super fast on inference because this model has no request limits. The F-score, however, was not so good. Like, so the model was the fastest guy in the West, the most accurate one. But it is feasible, yeah, comparing, taking into note its speed and size. And also, what is important is that we limited the amount of topics that the model could fantasize sometimes and think of the topics that was not even astronomical ones. So, yeah, we narrowed down the problem to like multiplex classification. An interesting insight can be drawn when we inspect the least popular topics by the class. For instance, we have a topic which is potentially hazardous asteroid, and I would think that, you know, these telegrams would definitely be assigned as the most cited ones. But it appears that not, and it gives us the intuition that maybe the rare topics or the topics that we could think of as rare are not actually mean that the telegrams would be cited or would be impactful. And another chart shows the most cited topics per year. You should not read through all of them, just have the general idea that the most cited topics are changing each year, so there are some trends in astronomy, and we will have to find a way to capture these trends. So another approach, I mean, the following, the subsequent approach that we employed was the Doc2Vec. So basically we need some sort of representation of the whole telegram body for the prediction test. We chose the algorithm which is called Doc2Vec UKUU. It's basically one of the most powerful algorithms before the large language models era. So we employed the implementation provided from the Stanford University, and we trained the embeddings of size 256. The first thing we did with the embeddings is that we projected them on a 2D space. In the ideal case scenario, we wanted, to see the perfectly separated cluster of interesting and not interesting telegrams, but of course it didn't happen. However, we noticed some interesting cluster, and by closer inspection of this interesting cluster, we also did some good conclusions. So first of all, the vast majority of these telegrams had a combination of the gamma ray burst made with the Swift telescope, which references us to that the combination of its source and telescope are more powerful signal than the source and telescope alone. And the second thing is that also the majority of the posts belong to only 4 different authors. So we can say that there are some authors which are probably more successful in terms of their citations. Maybe they possess more powerful resources to do researches and so on. Another step from information extraction was to train our own Doc2Vec. So as we extracted some entities, some named entities, some topics, we needed to preprocess them for the citation prediction. In this scenario, we employed the Floret method, which being a competitor of the famous globe fast text vectors, but it is a bit faster stuff. So we utilized the provided implementation. We create 2 versions of the embeddings for the further comparison. How did we assess the quality? We selected some set of values, for instance, the pair of telescopes or the pair of connected sources that look very different from the semantics perspective, but we know that they are telescopes, and we compare them with some default spacey vectors or some dark model vectors. And as you can see, our train embeddings show some good similarity while the default are not. So we assume that our train embeddings know some context. And the last part of the information extraction was to create some features, some meta features starting from the telegram length, citation count, and months, following with the time series, like trends features. As we said, the trends are important So time series features are aimed to catch the author-based or the topics-based trends. A quick exploration of the correlation with the target value. You can see that the ref count, which stands for amount of references in the Telegram, is the most correlated feature with the citation itself, which is quite fun. Like it's like the more authors, the more other telegrams you will pick or you will tag in your job, your work, the more you will get tagged later. And another like interesting study we found is the telegram length. You can clearly see that the telegrams became much longer through the last years. We don't know like why it's happening, but it just another support of the idea that the astronomer might need some tool to analyze the telegrams as they become much longer and harder to read, probably. And now the final part, station prediction. So first of all, we compare the different methods and encodings that we created with some baseline methods for encoding the named entities and topics we extracted. Yeah, in both cases, the flow rate with the embeddings of size 128 as one as the best method. So the final data set that was used is being composed of the telescope vector stacked with the source vector, stacked with the topics vector, stacked with the document vector, stacked with the 18 of handcrafted features. Now getting closer to the experiments itself, we did a classification problem. This time we picked the balanced accuracy as a metric due to the classes imbalances. We also used some sampling techniques to counter the unbalancing problem. And we did the classification for both binary and three-class targets. We also tried to train a regression model just to see how it goes and probably utilize it in a future stacking solution. For regression, we use the most interpreted metric, the mean absolute error as a metric. So the first iteration of the result showed that the accuracy of the binary classification is the most, let's say, acceptable one. The multi-class was mostly, let's say, noised by the very highly cited telegrams, and the regression model shows that we are mistaken in two citations in average. Yeah, if we predict the mean, we will be mistaken in 3.5. Yeah, but it's still like two citations, maybe good, maybe bad. So exploration of the feature importances of the model shows that the document vector is the most important ones. However, also the count of references and some trend-based feature that we created also has some importance in the training. In the second iteration of the model training, we did stacking. Yes, so following the stacking pipeline, we trained the meta model based on the YGDM, and we did the predictions on the same test set as before, and achieved this time a better accuracy of 83.3, which means that we did almost a 4% increase. We achieved like pretty good precision for the class 0, which aligns with our like primary needs to probably filter down the not interesting telegrams, to save times for the astronomer or potential user of this functionality. And we also have some decent recall for the class of interesting telegrams, which means that we would not, our like recommendation system or whatever it would be, will not miss the majority of interesting telegrams. So about the conclusions, we did all of the goals that we set in the goals part. Yes, so we predicted some value expressed by the citation rate of a telegram. We extracted information and we did it all on our manually created dataset. And about the future work that can be done in this direction is that we can employ some scheduling stuff to continuously update the dataset and retrain the model. We can incorporate more advanced NLP techniques if we would not be limited in the budget. For instance, we can extract the topics of the named entities with the GPT-3. Of course, it would be much higher quality of the extracted feature. And yeah, we can enhance the model interpretability, maybe do some information retrieval techniques to explain why this telegram would be interesting or not for the astronomer. And the most important part is that the Telegram interest prediction, or the impactfulness prediction, is in our case, it was built primarily on hypothesis that the citation rate is the best determinator of the Telegram interest. Well, there could be a lot of other possibilities. We could make some unlabeled some clusterization problem. We could make some recommendation or ranking system. So there are a lot of alternatives to explore. And basically that's all. Thank you all. Thanks for my supervisor, and thanks for the researchers, astronomers from Europe who are watching us very much.
You said that these sources are very popular among astronomers, but we have seen a very steep decline in the number of posts during the last 2 years. So does it mean that they are losing their?
I got the question. Thank you. So I was wondering why it happened. I asked the man from the European, the astronomer himself, and he told me that it can be potentially connected to the first of all, like the data sources are constantly changing, appearing new different Telegram channels, WhatsApp channels, whatever, and it's harder. And for this, all two websites, they become harder to compete with them. And so I'm trying to add some ads, some other stuff, and the people are leaving them. So basically, this identify not that there are less telegrams. It identifies that there are more sources, and the old sources may become less popular in time.
Can the astronomers use your finding to compromise to learn what makes their posts more likely to be highly cited? What would you suggest to include in the post to attract more attention and potentially raise citation?
Well, I'd say that with the solution, the current version of solution is not quite possible. Got some stacking approach which does not says nobody me. But it was mentioned in the future work that we enhance the invertibility of the solution. Then we can say that the telegrams with this some features, some multi, and so it could be a recommendation for the astronomer how to make this job side. From what can I say now, right, is to cite more publicly. If we've seen that the more you cite someone, the more likely someone is to.
And the number of citations itself is probably not the best. The best indicator. There are, like in academic publications network, there is this H index, which is taken as an indicator of importance. It's not on the level of publication of itself, but on the level of the author. You mentioned that there are a few authors who actually post the majority of the content. So it might be that they just cross-reference themselves and also refer to the previous post. Although you said you included
self-citation.
Validation was
Excluded, yeah, but not. You said it is not self-citation, but as a post mentioning. I mean, if you
no, if author is citing his previous job or referring to it, we don't calculate this to the previous.
So the fourth element to telegram.
And when you identify the posts that are very highly cited, does it mean that there is some discovery and it is later reflected in the highly cited publications in some journals? Or so is it yeah, because I understand that this is purely academic question, the citation index in the channel, Telegram source, but does it reflect importance of this discovery over some?
Well, we assume that it reflects the potential impact of the discovery. So potentially impactful discoveries will likely get more say. That was the hypothesis.
So could you check cross verify it from different sources like academic publications?
Well, I was thinking for some reason that the same applies to academic publications.
No, I mean that this highly cited post has some new finding, some discovery, which is the source for articles. I mean, which was later described in articles, in papers.
Well, that's a good idea for research.
If I got this correctly, you were splitting the project. I mean, this thesis has been done on a project with some astronomers somewhere in Europe.
Oh yeah, some of the values, some of the labels that they gave us for the named entity model were already incorporated in their existing solutions.
So were you at the bottom of the project? You mentioned some budgets.
The budgets. Okay, got it. No, it was the OpenAI model. No, they're not.
Okay, got it.
So
Okay. This is to ask you about the recommendation of your review. You mentioned this work is in fact looking into popular news items somewhere. So why not try any different domain or a different source of text streams? Did you think about that? Twitter, for instance?
no,
Or the fourth stage of genocide? Yeah?
no,
Just as astronomy.
yeah.
Is it, I mean, the approach more of the use trained, is it expandable to differently? What are the boundaries of the applicability?
Each of the models that were trained are can be trained for a different domain, obviously. But the solution itself is purely very domain specific.
Thank you.
About the task. One of the main results in this then try to predict the citation level of the post. It depends just on the text because yeah. Text plus some features that we did, like the map. We created some features, same things. Yeah, but like method features that are not made of the text itself, but rather than like the post date of the telegram node. Yes, the values are specific, but this is it's not like history of this quarter, like other posts of the same author. Yeah.
So could you repeat this?
This trends.
Author-based trends. What is this trends? What is author-based trends? How to understand?
Okay, so I got some slides. So how did we calculate the trends? So, for instance, let's take a month's period, right? So at the moment when the current telegram appears, we have some old time period, months period. We can calculate the citation rate for the months, yeah, and then we can calculate all time citation rate, and then if we divide the month citation rate by the whole time citation rate, yeah, we got some ratio. If ratio is below 1, it means that this month is relatively more active and more popular. Yeah,
It's like a time series to all these.
Yeah.
As a feature for an.
yeah. So this features were calculated in time series manner, and the same things were applied to the outcome for topics.
Am I right? This the feature is the most influential of the result, no?
No, the feature that is most influenced is what the amount of citations that are made in the telegram. Because all the, yeah,
Okay.
The more it's like, the more it's.
Yeah, like,
Artificial citation.
okay, okay. And, the main question, what is this, idea? Of course, authors, most probably interested in high citations and so on. So, who is interested in these results? Maybe astronomers, like astronomers, they study. If they will take these results and try to implement could it be the situation that let me say they will tackle these parameters when I should put this post, how I would like to write it, and so on. To tune, yes, to tune, like it's not maybe like increase parameters, but understand how they should do if the model is like some kind of rules. Yeah. So how they should behave to increase this metrics.
how they should behave. Well,
Where they should write and so on.
yeah, well, probably some very straightforward features like the mask of the post is like it matters. Yeah, so they can pick the month when they post something. It will likely, it may be more silent if the months is generally more silent than the other months. The same goes with the NER results. Yeah, if we further explore like the relationship between some telescopes, for instance, and the citation rate of the telegrams, some authors maybe just include the telescope just in the post. Say like I did it with Swift, but like if I had it's better. Yeah, it already like will contain the Swift and
The whole different analysis, yeah.
yeah. Yeah, it's possible like that, but there has to be done much more like work for interpret the results.
I asked a similar question, but is it the case that there are the most cited posts come from people working in, say, same laboratory, or they just have different shifts when they monitor the sky, and then simply that always come from few places and dominate all the network? Maybe that's the reason why the other will lose interest, because they are not here, not seen there.
Yeah, it's a good question. Actually, here we use not the authors like the name and surname, but the credential information of the one who posted.
For instance, if there is some research center or some university, there might be like a dozen of different astronomers, but they all post from the same email. So the object here is the email, and like so it should be dealing with the case of like different outlets and like.
Whereas in the motivation is the same, even for the legal topics, to increase the popularity, increase the impact, so to increase the budget. Yes. And not only for astronomy. It needs to increase your citation rates and well-known and frequently practiced in different branches, not only in astronomy.
Yeah, it's good to be supported by machine learning model.
All that. Yeah. Could be great if we have written technical text, which is evolving in terms of impact of situations.
I don't ask question.
No.
Maybe one more question. I remember some discussion of this anti-plagiarism stuff, and one good point was that sometimes a false statement is very often cited, and therefore this plagiarism actually is these systems are trained in the wrong way. I mean, vice versa. If somebody includes a correct statement, something like definition or something, it is found on multiple sites, multiple sources, and is regarded as plagiarism, something like that. But if a student writes nonsense, which is not found in the internet, then the system cannot find it. Okay, so my related question is, what if to increase the citation, somebody posts a nonsense, and then 100 of people just cite this as nonsense?
Well, then it will be a kind of side effect.
So it's the cheap way to increase the citation.
We don't possess any functionality for really some semantics analysis or whatever else, identify whether the set in the post is astronomically true or not. We just like using only the values. So yeah, in your case, it would be like a pure cheating, literally in higher situations.
They want to say something as a supervisor.
I don't know, is it the suitable and appropriate?
Why not? Here. Yeah, it's got input. Okay.
Okay, so I can say a few words. So first of all, about the task was inspired by astronomy group who actually created the system for knowledge of astronomical sources, and they tried to attach the sources to the most cited papers. So scientists who work, for example, with black holes can read all the latest papers in one place, and this was what they done, and they wanted to somehow attach these papers, which are not papers, but it's like pre-papers. So they want to establish made observation, and papers like both story. So astronomy is the event. That's the reason why we tell those kind of things, because when you make an observation, you want to establish your first hand. It was you who found this new star or something like that. So we try to work with this
and I can say that Vladyslav made a very good work on attacking this problem from other side, from different sides. We tried one approach and another approach, and we had there my client, so I can only say good about this attitude towards this problem.
So, yes, yes.
Thank you.